Like 3/5.
3/5. Okay. Anybody else got a different answer? No. Okay, I'll take that as a no. So this is what they gave you and they told you to evaluate. Okay. Can anybody tell me what's the first rule, the first law that you applied here? Okay, let me just do it. So we know the 8th law that I showed you. It said a to the power of, okay, hold on. I want to show you, I want to do the exact rule. Oh gosh, what was the exact rule? I want to write exactly what I had there. Okay, so a to the power of n divided by b to the power of n. So a and b, that just indicates that these are different. They have different bases, right? It's the same as a divided by b and this whole thing to the power of n. And I could apply this rule first. Looking at this rule, according to this rule, 125 divided by 27 and this whole thing to the power of minus a third is the same as 125 to the power of a third divided by 27 to the power of minus a third. So that's the first thing there. But we don't just stop there. We could apply another rule. So yeah, you could just punch this into your calculator and get the answer, but no, that's not the purpose of this class. It's for you to be able to use the laws of indices to solve problems, right? So the next law I could use is this one. A t minus n is the same as 1 and a to the power of n. What does that mean? According to my rule, 125 to the power of minus a third. So we're treating this whole fraction, so a third, we're treating that as n, right? So if I have 125 raised to the power of minus a third, this is supposed to become, according to this rule, 1 divided by 125 by the power of n, and we said n in this case is a third. So that's raised to the power of a third. Any questions? Please stop me. All right? So let me just use this. We could do that to the denominator as well. So just so I don't confuse you, I'm just going to put the division sign. 27 raised to the power of minus a third. That would be the same as, following this rule again, 1 27 to the power of a third. But we don't just stop here, because we could simplify this even further. So like I said, you could very well just punch this into your calculator, but that's not the point of this class, right? We know this other one, this other rule that says a to the power of 1 on n is the same as this. So according to my law, and then looking at my question, I can say, let me go up here. I can say that 125 to the power of a third is the same as, so I put my 1, the cube root of 125 And don't forget, this is also divided by this. 27 to the power of a third. This will give me cube root of 27. So this is where you could use a calculator now. The cube root of 125, that's 5. So this becomes 5 divided by the cube root of 27 is 3. A fifth divided by a third is going to give me 3 fifths. That is why this answer here is correct. So how was that? Anybody lost? Yes, no?
I got that.
Fine. I'm fine.
Repeat? You're talking at the same time. Can you repeat what you said, please?
So Miss, I didn't say anything, Miss. I said I'm following.
All right. Okay. So no questions on this. Cool. I'm going to erase this star. Stop me if you have to stop me. I'm going to erase this. Okay, I erased it. I'm just going to clear the whole thing. Could anybody tell me what they got for the answer for the second one? Anybody got an answer for the second one?
I got 8.
Okay, we have 8. Anybody else got an answer? That was not 8. Oh, if you got 8 too, let me know. Anybody else got 8? Okay. Top crowd. That's fine. So we see different bases here. We see an 8, we see 32, we see 16. That is not what we want. We want the same base if possible. So now we need to check. Can we write 8, 32, and 16 as the same base? The answer is yes. Let me show you. 8. 8 is the same as 2 raised to the power of 3. So I could write it like that. And this whole thing is raised to the power of half. Multiplied by, I could also write 32 with a base of 2. 2 to the power of 5 is the same as 32. So the whole purpose of me doing this is so I can get the same bases. If I have the same bases, I could apply my laws. There's just one way to do it. I'll show you the other way. So this first method, I'm trying to get all the same bases. 16 is also written as 2 to the power of 4. So now I have the same bases, all of them to the base of a base of 2. So I could apply my laws and simplify this. Well, evaluate in this case. So this is just one way of doing it, right? Okay, I need space. Let me continue. Okay. We know this rule. A to the n, and this whole thing raised to the power of m is a to the n m. So I could apply that rule here to get 2 to the power of 3 on 2 multiplied by 2 to the power of 5 on 2. And because I have no space, I'll just write it like this. This whole thing, that's my numerator, and it's going to be divided by 2. 4 multiplied by a quarter is going to give me 1. So that's 2 to the power of 1. That's just me applying this rule, right? So now I'm going to erase the yellow part because I have no space. What's another rule I could apply here? Is the first rule that I taught you. So a to the power of n times a to the power of m, that you add the indices. So this is what you get. Let me continue this in green. So I would add these powers to get 2, 3 on 2 plus 5 on 2. That's going to give me 8 on 2. But we know a divided by 2 is the same as 4. So I could write this as 2 to the power of 4. And this is still divided by this. Last rule I could apply here, to simplify even further, is this one. A to the power of n divided by a to the power of m is going to give me a to the power of n minus m. What does that mean? I'm going to subtract their powers. So this is going to give me 2 to the power of 4 minus 1, which is 3. But of course, we don't just leave it like that because we know that 2 to the power of 3, or 2 cubed, is 8. And that's why this answer is correct. So, questions? Any questions?
No, miss.
Okay. Okay. No questions. I could erase this. Anybody writing?
Yes, miss. You can erase it. Finish it.
Okay. When you finish, let me know.
No, miss. I'm finished, miss.
Oh, okay. So I told you that's one way of solving it. This is the other way. Beauty of maths, right? Multiple ways to solve one question. It's amazing. Okay. Erase, 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 erase. So instead of doing that, I could apply the rule. So instead of converting all of them to the same base, to the base 2, I could apply this rule because we know this rule as well. A, b to the power of n is the same as a to the power of n multiplied by b to the power of n. So what does that mean for me? That means that a to the power of a half multiplied by 32 to the power of a half, both of them have the same powers. So I could say, according to this rule, that this is the same as 8 multiplied by 32, and this whole thing raised to the power of a half. And then you still have your divided by 16 to the power of a quarter. We could simplify this even further. Why? 8 times 32, that's 256. 256. And we raise this to the power of a half. That doesn't change. All I did just now was say 8 multiplied by 32. So I have 256 divided by 256 to the power of a half divided by 16 to the power of a quarter. So what I could say now is that a to the power of 1 on n is the same as this. So 256 to the power of a half, that's the same as saying the square root of 256. 256 divided by 16 to the power of a quarter. The square root of 256. Hold on. Square root of 256, that's 16. So that's 16 divided by 16 to the power of a quarter. Then I could apply this rule. A to the power of n divided by a to the power of m. What I do, I subtract the indices. So remember, it's understood that 1 is here. 1 minus a quarter, that would give me 16 to the power of 3/4. And if you punch that into your calculator, you're going to get 8. So how was that? Everybody understand what I just did?
Yes, miss.
Yes, miss.
Okay. Okay. Instead of doing this, instead of saying 256 to the power of a half is the same as the square root of 256, I'm continuing. If I wanted to, erase out. Like I said, beauty of maths. It's so many ways to solve one question. So many correct ways to solve one question. I could have said, okay, 256, and I have a base of 16. If I wanted to get the same base, 256, I could write that as 16 squared, because 16 squared is the same as 256. So instead of finding the square root of 256, I could have said, okay, 256 is the same as 16 squared, and this is still raised to the power of a half, divided by 16 to the power of a quarter. I applied this rule here. So 2 times a half, that would just give me back the 16 divided by 16 to the power of a quarter. And that's the same step from just now. It will give me 16 to the power of 3/4, which is 8. So many ways of solving one question. So everybody understand this method? Like this yellow part right here? That's the only thing I changed just now.
Yes, ma'am.
Okay. So that's the end of that. Okay, no, that's not the end of that. I didn't even remember these. Okay. How much time? All right, well, this is what I think this would be the last thing that we would do, because I don't want to go over the time. So attempt this. You could do it. You follow the same rules. And when you finish, let me know. This might be the last thing that we do, because I would go over the time, and I don't want to go over the time. So do these, A and B. You can send me answer on Zoom, send me a picture on WhatsApp. Zoom. So this is the question that they gave you. They told you that y, but it said given that y is equal to 2 raised to the power of x, they want you to express this to this expression here. 2x plus, well, if you understand your answer while going through, it's okay. You could send me while going through the question, right? So they give you this expression 2 to the power of x plus 1 plus 4 to the power of x minus 16 to the power of x minus 1. I told you that y is equal to 2 to the power of x. And what do they want you to do? Express this in terms of y. So they said express in terms of y. So what your aim is to get this, the 2 to the power of x. So you could incorporate the letter y in your expression. So let me show you what I mean by that, right? So you simplify like we were doing just now using the laws of indices. The first thing that you would do to simplify, okay, so you take it term by term. So the first term you're seeing is 2 to the power of x plus 1. We know this rule. A to the power of n multiplied by a to the power of m is going to give me a to the power of n plus m. This is the rule I would apply for this term, this first term right here. I see 2 to the power of x plus 1. So what I could say is that this is the same as 2 to the power of x plus 1 is the same as 2 to the power of x multiplied by 2 to the power of 1. Let me just put that in brackets to separate. Everybody good with what I just did?
Yes, miss. So far.
Okay. If anybody not seeing it, please let me know. So 2 to the power of x multiplied by 2 to the power of 1. If I apply this rule, that would be the same as 2 to the power of x plus 1. So then you're looking at the next two. Oh gosh, wait, yellow. 4 to the power of x. Remember, the goal for this particular question is to get this, the 2 to the power of x. That's the only way you're going to be able to express this in terms of y. So what you could say here, okay, 4 is the same as 2 squared. So 4 to the power of x is the same as saying 2 squared to the power of x. Everybody go to that one. Yes or no? Yes, no, maybe. Do it again.
Yes, miss.
Wait, do it again? Or you're good with it?
Miss, I'm good with it.
Okay. So this one now. So what I could say, I could apply this rule first and say 16 to the power, actually no, let me not do that one. Let me change this to the base 2 as well. 16 is the same as 2 to the power of 4. 2 to the power of 4. All I did was change 16 so it has a base of 2, right? We're talking about bases just now. 16 is the same as 2 to the power of 4. That's all I did. So 2 to the power of 4, and this whole thing is raised to the power of x minus 1. So this would be my next line. We know the rule that I have to put on the slide is that a, so anything raised to the power of 1 is itself, right? So a raised to the power of 1 is going to give me back a. 2 raised to the power of 1 is going to give me back 2. Anything raised to the power of 1 is itself. So 2 to the power of x multiplied by 2 to the power of 1, I could rewrite that as 2 times 2 to the power of x. Everybody understand how I got this? Yes, no? Okay,
Yes, miss.
I'm going to stop this and rejoin just for me to finish this question.